To help you in your decision of which method you like to use for factoring quadratic expressions, I thought for this final video we would do a side-by-side comparison of the two methods. So again, these are the two methods we're going to use when the a value in your quadratic expression, even if you take a GCF out, is bigger than 1. Okay, if you had an a value of just 1, you can go straight to the two binomials and a t-chart and find the answer. You don't have to go to all these steps. Okay, so I've got the same question under both headings, split the middle term and the Berry method, and we'll highlight for you how their steps go. So working across, the first step in split the middle term is exactly as it sounds. We're going to take negative 10x and divide it up into two numbers that will add to give negative 10, like this. In the Berry method, our first step is to make that intentional error. Reduce the degree of this polynomial by 1 so that it reads 8x, and put it at the beginning of both binomial factors, recognizing that you've got an extra power of 8 that you're going to have to eliminate at the end of your answer. Now this is where both methods are identical. They both require the thinking chart to get through the next step. So we need to find two numbers that multiply to give 8 times negative 3, or negative 24, and that add to give the b value of negative 10. Because they multiply to give a negative value, we know that one of them must be positive, one must be negative, and the larger one must be the negative one. So I could start with 1 and negative 24, but they won't add together to give negative 10. I could then try 2 and negative 12. Those will add to give negative 10. So my next step then is to put 2 and negative 12 into this step. Doesn't matter what order, I'll just put them in the way I discovered them. So plus 2x minus 12x goes here, and plus 2 and minus 12 goes here. In split the middle term, what I would do next is I would look at factoring by grouping. So for each pair, I need to take out a GCF. The GCF for the first pair numerically would be a 2 and literally would be an x. I would then have to multiply 2x by 4x plus 1 in order to get 8x squared plus 2x back. Similarly, the GCF here is negative 3. And I know this because what I end up with here in this binomial should match exactly to the one that's here when I'm factoring by grouping. So these both have a GCF of 4x plus 1. It's a binomial GCF. We can take it out, and we know that it in turn needs to be multiplied by 2x to get that pairing, and by negative 3 to get that pairing. And that's the split the middle term method. To finish up Berry is a little bit similar too. We're going to ask ourselves, are there any GCFs in these binomials? The GCF of this one is a 2. So I have 4x plus 1. And the GCF in this one is 4. Again, notice the use of brackets all the way across to maintain all those multiplications. And I have 2x minus 3. To finish off Berry, I have to remove that extra intentional factor of 8. It is located here and here. And so my final answer comes out to 4x plus 1 times 2x minus 3. And upon quick inspection, you'll see that you get the same answer using either method. In terms of amount of work, I think they're both very similar. You can say they both require 4 lines of thinking to go from the question to the answer, and they both require the t-chart. So as I said at the beginning of this lesson, it doesn't matter to me which one you use the one that makes the most sense to you. If you have any questions with the practice, again, don't hesitate to contact me and I'd be happy to help you out.